Hi, I'm Kris Gillespie from yeah? Okay, check it on two, can you hear me back? Hi, I'm Kris Gillespie from Ball.com. I'm here to talk to you guys about, well, mainly Ceph, because we haven't deployed any Openstack or anything like that, so, well, it's just going to be about Ceph. What am I going to talk about? First, I'm going to talk a little bit about myself, because then it will give my presentation relevance. I'm going to tell you a little bit about Ball.com, just so that you know who we are, because it's relevant for the next few bits, which is about our legacy storage, and about our future storage that we're looking at. We haven't made any decisions yet. And of course, old man ramblings, because I'm great in my beard, so I can call myself an old man, about Ceph, SDS, and the new wave of storage in general. So first, for those of you who have been living under a rock, Ball.com. That's the slogan in Dutch. I'm not going to embarrass myself by trying to say it, but it basically means the website for everyone. Shop for everyone, excuse me. That's how it looks at some point. And we have multiple apps, so we have multiple ways of getting to our stuff. Of course, this means that we have to have the infrastructure behind it to support this. So as people dream up new ways of getting to our shop, that means that our infrastructure has to expand as well. We, of course, try to sell all the things, and that will increase. As that increases, our infrastructure will increase as well. So, as the business expands, so does the workload that we have to run on it. So, that's the formal part out of the way. So now I'm going to talk a bit about the legacy storage. So this is what we have now, in not too gory detail, but just so you understand where we're coming from. So, we run a NetApp-based storage platform. So we have multiple NetApps across multiple data centers. So we have your traditional production and DR side. We have used SnapMirror and SnapVault, which is basically just a way of replicating data to get our data from the production to the disaster recovery or to our backup sites. We have around 1 petabyte of raw storage. It's not accurate though. Well, it's accurate, it is raw storage, but everything is thinly provisioned, so the real amount could be God as well. Everything is connected by 10 gig Ethernet and think traditional. So this is your standard storage infrastructure that you've seen for the last 20 years. Production, DR, backup. About 80% of our storage is used by Oracle. About 90% of the performance is eaten by Oracle. And about 120% of our time is eaten by everything surrounding Oracle. We're not very happy about that. I don't know if you can see the picture behind it, but it's quite funny. And of course, we have challenges with this infrastructure as well. We have the growth, which basically is a pain in the neck, due to how the NetApps are set up. The snapshot usage means that our storage, basically how much storage we use, is very hard to understand, not to understand, but to predict. Because when you have a snapshot, if the volume above it is changing a lot, then the rate of change will of course increase the size of these snapshot deltas. So at different times of the year, different things have different growth, and so it makes doing capacity management a nightmare. And of course, cost. These things cost a fortune. That would love to charge you a lot of money for these things. So that brings us to our future idea, because we're getting kind of sick paying for a lot of money for less flexibility. So let's have a look. So we asked internally, what are the actual requirements for our new storage platform? It needs to be scalable. So we need to be able to just add capacity in order to get more IOPS and more terabytes or petabytes. It needs to be API addressable, because we want to automate everything. We have a lot through Puppet, but in the future that could be pretty much what. So it needs to be addressable via an API. That's something that we really care about. No single point of failure. With our current infrastructure, if we lose a rack, then we're screwed. So we don't want that in the future. It's too much of a risk for our business. It needs to be relatively inexpensive, because euros always matter. It needs to be flexible, so we need to have multiple ways of accessing our data, or to be able to provide data to the various applications that we want to run. So be it block, or object, or God knows what. And it needs to be interoperable. It needs to be able to work with all of the various things that we might want to use in the future. I mean, maybe we decide to say have a software-defined storage side over here, and we want to have a traditional storage over there. So it needs to be able to work with everything, or at least as best as it can. And all these requirements come from our business, because we have more and more requests to develop more and more applications in order to sell our products through the various channels that we have. So we need more agility and quicker time to market. So in order to do this, We need a flexible backend that can allow us to do this. But of course, we have challenges. Oracle is the big elephant in the room, because we need something to handle that. We also have the issue that, even though Ceph has been around for a while, talking to people and finding people that have actually ran it in a large-scale enterprise environment that looks like ours is rare. We haven't been able to talk to really anyone. It's kind of unproven as well. So, getting hard data as to how it runs on the various bits and pieces that you might have is also a challenge to find. And as well, it's pretty clear, but hard data is not forthcoming. Trying to find benchmark data or information as to how you should deploy it, guidelines and things like that are pretty difficult to find. So, what about Ceph in particular? Because currently we've been looking at a few options, but we've been focusing firstly on Ceph. So, why Ceph? It's scalable. You can just add OSDs and just scale out your capacity and your ability to do IOPS. It is API addressable. There's the RESTful API and everything. No swap, as long as you're not using the file system where it has the single NDS or metadata server, then, well, but that's a design decision at this moment. It's relatively inexpensive. Don't know what Red Hat would charge for support for it, but well, from our point of view, it seems relatively inexpensive. It's flexible. We can do block, object, or if we're really crazy at the moment, file. It's interoperable. You can do S3 or talk Swift to it, it's possible. To the object store, or to the browser gateway, I mean. And it has a strong search interest. I mean, people are here. So that's pretty obvious. And why not? It's calamari. Fried squid. There are many unknowns. As I said before, understanding how it will work on your infrastructure is a challenge. I mean, for myself personally, I've spent the last 2 months doing across various bits of the hardware and various configurations, trying to understand how it will work and what the performance will be on our infrastructure. Or at least the current infrastructure that we have. Then maybe Intel released a new CPU, maybe there's a different NIC. So there's a lot of different combinations that you have to explore. And, that takes time. Which is, of course, another issue, which is the time to fix bugs in that. I mean, this is true for any open source. And I should actually, I realized I forgot to tell you that a bit about myself. I'm one of those beady Unix guys. I actually come from an IBM AIX mainframe background. So I'm not an open source fanboy per se. I see its place, but I'm not a believer as such. I like to judge everything on its merits. So because of that, I just see an issue with the time to fix bugs and the support commitment, because that's something that, as a business, is an issue for us. Or at least, I see it as an issue. Because if you're going to run your business and basically commit your revenue to something which may or may not get support, that's an issue. It'll be an issue for our management. And of course, scalability can bring all kinds of pains when it comes to rebuilds, but I'll talk more about that later. So what have we done particularly? Like, why can I talk about this? Well, we ran a POC for a while on our hardware. And, well, you can read there the specifications. Don't want to put too much detail in there because, well, we load the equipment and we don't want to say too much. But pretty recent Intel CPUs, quite a lot of memory. It's actually complete overkill because, well, these servers were meant for something else. 900 gig SAS, 200 gig SSDs, 1.3 terabyte PCIe flash cards, which are really nice. And we use 10 gig everywhere, although we are actually hoping, we're still finding out if we can actually use the InfiniBand, because as of the latest release, RDMA support is sort of there. It's like, don't use it unless you want to get data corruption, but we still want to see how it performs. And we did all kinds of benchmarks. So 4K, 8K, 1 meg, random read writes, sequentials. We did all kinds of different queue depths. We played around with 3-way replicated pools, 2-way, 1-way. Erasure coded with cache tier running on the flash cards. We tried the J erasure and the ISA, which was the Intel accelerated erasure coded pools. This did the most fun one from my perspective was the cost IOPS terabyte calculation based compared to our current NetApp infrastructure. It actually cost us to run this versus our current one. Basically, so we have a nice card to play if we want to act, well, if we actually really decide to use this. because, well, it's all about money. And we will present more benchmarks when they're pretty, because currently they look ugly as sin. This is from FIO. If you download the latest version of, or if you git pull the latest, git clone actually, the latest version of FIO from GitHub, and then in there's a FIO create plots or something, and it uses GNU plots to make these graphs based on the log files from FIO. But it goes kind of wacky with the labels. I mean, if you look at the top, it says EC1M256 with all kinds of weird it looks like scientific notation. It's actually on an erasure code pool with 1 meg block size, 256 Q depth, and I don't know what that is. And on the left side is the actual throughput. So it goes up to over, well, this is about 10 gigabit, no, this was a 1 gigabyte, or what is that? 4, maybe. We're basically maxing out a 10 gig link. I'm too lazy to work that out. But it's basically maxing out a 10 gig link. So we can saturate it. And here's just a few little other bits and pieces about all the various things that we've been testing. So, we've done nice hard IOPS testing. And these are across only 3 nodes. So we did a lot of testing across just 3 nodes, just to see what each building block can give us. Because our idea is to build our infrastructure in building blocks. So, we saw that we could get about 20,000 IOPS. We saw that the latency, if you come down here, you can see the max latency while we were hammering it was only about 1 second, which is pretty nice. And this is on an erasure code pool with a PCI flash cache tier. So that actually goes very nice. Because here, for example, if you look at the hot storage is the PCI-based flash. And that's basically overlaid on top of the EC pool. And this was taken before I did the testing on the ISA code, but you didn't see a huge difference in performance because the cache tier just ripped it up. So it's really good. And also in one of the, I think it was in the last release, snapshots on the cache tier is also supported, so that actually makes it very interesting for us. And the challenges that we've dealt with so far is dealing with journals. And it's probably something very specific that we've encountered, but because we use PCIe-based flash, which can do something like 800,000 IOPS a second at ridiculous speeds, we can fill it very quickly. And when Ceph wants to basically sync the journal, it stops the I/O. And across our little 3-node cluster, when that stops, so we watch the data go, stops. And then off it goes and bam. So it's actually spec, but I mean, if you look at the more, I hate to say the word enterprisey, but other storage systems will not stop when the journal is full. They have like, watermarks and they will slowly trickle it out, but they'll still accept data to come in. So that feels a bit, don't like it. Crush maps. We played a lot around, but also building up various crush maps. So for example, to define our infrastructure based on DC, rack, host, OSD, and then split it up between these are PCI flash, these are SSDs, these are regular spinning Rust. And then so then we can create rules to then say, okay, this pool goes to this set of disks, this one goes here, this has this and that, But that configuration doesn't get reflected in the actual OSD startup scripts. So if you have a node failure and you redeploy things, or if you say, you just reboots, the OSDs will start up again with the wrong, or the default rule sets applied to them. So then you have to go and push crush maps again and hope that it isn't rebalancing. You have to catch it, say, don't rebuild, don't backfill, don't do anything. Until you push the new crush map and then it'll all be fine. So that's a bit, it just needs to be automated. So if you make that change, then it needs to reflect it in the configuration of the OSDs. Otherwise, people might not think of that and wonder, why is my thing rebuilding all the time? Rebuilds. It seems to be all or nothing. So you can say, if you lose a host, so okay, fine, just do your backfills and everything, that's fine, or not. But what we want to see is bandwidth throttling, which I haven't seen. But if anyone knows of it, please tell me. If I can fix that, that would be a huge, huge thing for me. And I guess for all of us. Intervention rebuilds are kind of a pain. And also getting people to understand its place. which is something that I'll talk more about at the end. But it's basically understanding that Ceph isn't the solution to everything. It's not your only storage option. But okay. Okay. So now, almost done. In case any of you aren't native English speakers, the co-merchant is a grumpy old man, like the guy sitting there as well. So, like I said, I'm not an open source guy by nature. I come from more of your enterprisey kind of world, so maybe I'm not the right person for this, but I am. So I just want to get it off my chest. So this is my getting it off the chest Ceph edition. Ceph and the like are for everything. I mean, the biggest issue that we have is Oracle. What do we do with it? I mean, for us, it's about 80% of our storage infrastructure is Oracle. And I'm sure that there are other places out there that have a similar legacy thing that just will not go away. So this needs to be dealt with, or at least we need to deal with it. But probably Ceph is not going to be the solution for that. I've also noticed that single-threaded performance, as far as, just like a single host doing just like, say we have a database that wants to go off and do a nice big fat table scan, performance isn't as good, which makes sense because Ceph, the idea is multiple hosts, lots of concurrency, your aggregate performance is very high. And of course for the risk averse, because as I said before, it's open source technology. You're putting your trust and your business in the hands of people that may or may not support it. Of course there's Red Hat, but still. And of course you've got choice paralysis, which is you have so many options as to how to deploy Ceph. And not just how to deploy it, but also hardware options. I mean, if you go to your traditional vendor, so you go to EMC and you say, I want block-based storage that will do 50,000 items, and it needs to be so. They just go, great, this, there are your options. And then you sort of know how to work. With this, I like it, but you have so much choice and so many different variables, and even variables can change, like maybe a kernel gets updated and then slightly different, and then it messes with your network driver and you have increased latency, and so on and so on and so on. You don't know. So there's more variables, and also from the hardware perspective, how do you know that this is the best CPU, motherboard configuration you can get for your PCI cards? Because maybe this motherboard has it that the PCI Express cards are on the Ryzen board, and that has increased latency. Maybe on this Intel chip, the cores 1 and 2 are on are connected to this PCI bus, and otherwise you can do newer. And there's so many different options that could affect the performance. That how do you know that you're doing the best thing? How do you know that you're making the right choice? So that can be a bit of can mess with your mind a bit. And of course, how do you test it all? I mean, if you are an obsessive engineer, then you want to know that what you're doing is the best possible solution that you can. So you don't have endless time. At some point, your boss will go, Chris, so what are we doing? What's the options? You're like, I think more time. You can't do that. There's also no standardization, which of course is a good thing, because it goes both ways. No standardization, you do what you want. What do you do? And of course, it's a bit harder to sell internally, because like the old saying, no one got fired for buying IBM. And the last one is the skills are harder to find. I mean, trying to find people that actually have real long-term, or even medium-term, or short-term experience running a large Ceph or any SDS cluster in a production environment where that environment is making a lot of money for the company. Where are they? That's at least what we've noticed. Again, please correct me. Please correct me. But still, Ceph is still awesome. It has a place in the data center, and it has a very big place. For your rapid deployments, for your build environments, for anywhere where you want to do testing, probably also for large parts of our infrastructure that we don't have any kind of support contract against. Great. The adoption will grow. I mean, more and more people seem to be getting more and more interested in Ceph. And it's also easy to start small. Due to the scalable nature of Ceph, you can start with just a 3-node cluster and go from there. You can dip your toe in with relatively low risk and go from there. It's quite easy. The roadmap also looks very strong. I mean, now they've just put in RDMA support, which makes it very interesting also for us, because latency is a killer, especially when you're doing 3-way replicated pools. And especially when you have PCI or very, very fast flash, it's very frustrating to see you've got something that can do so many thousands of IOPS, and every time it has to do a check, or you have to do a three-way replication. And that kills it. So that's where for us, InfiniBand is very interesting. And of course, there's more things coming, hopefully parallel reads, and also cache tiering improvements to fix the hitbox stuff and all the rest. And the performance is there. I mean, even though I'm moaning about the fact that latency is high with the PCI stat, even still, we can easily saturate with 3 nodes and a couple of PCI PCI flash. We can saturate a 10 gig link. So, we're pretty happy with that. And it's stable. I mean, I've done all kinds of tests with pulling out cables and pulling out servers and everything, and it just runs. It runs, it's stable, even though the rebuild can just kill your performance, it still runs, it still works, it still serves the data. So it does, from my experience, how it looks, very stable. So for us, it does look like a very, very good option to a point. And really, that's it. So this is where we are. And what I would like to do also in maybe future meetups is explain how much further we've gone, and also the results of more of our benchmarks, because if I go back, I've done a lot. And I've tried to also do the benchmarks in a way that are also relevant to companies like us. But it's not pretty. I need to work on it to, massage it, to make it look better, or at least presentable. So in the future, I would like to do a follow-up session to go more in depth into all the benchmarking that we've run, and also share the information with the communities. I think that's something that's very, very useful for a lot of companies that are even thinking of doing this. Because for us, we haven't found a lot of this information. And otherwise, that's it. So that's who I am. If you want to get in contact with me, well, feel free. I'm Australian, as you probably guessed by the background. And yeah, hope I haven't wasted your time. That's it. Next. Well, unless you guys want to have a quick chat. No?
So I was looking at the graph, and the last one you were showing. Yeah, so it's only 20 seconds time span.
Yeah, because it went really quickly.
Yeah, it went really quickly. So it's like the 10 gigabits limit of the network, the upper boundary. Don't you feel the RAM of the nodes only in 20 seconds plus the cache?
Well, if you look here.
Yeah. Sorry, but I can't read this data because I don't know how to read.
Okay.
So I was only.
So this one ran for 600 seconds.
Yeah.
It wrote, well, that many IOPS. The write size was, I believe this is in kilobytes, so it wrote like 4 terabytes. In general, the average latency was half a second. The minimum was like 0.04, and the maximum was 1.1. So, and this also had a maximum bandwidth of 964 megabytes a second, and it averaged about 879. So,
and the what's the write size?
The write size was.
Is it 4 gigabit?
Well, this is the Rattlesnake tool, which I believe is 4K. Yeah. And the other one was with 1 meg blocks. Because I really just want to push as much as I possibly could down.
How many placement groups you have? On these pools?
103
nodes.
128.
It could influence the peak.
Yeah?
Ja.
Well, we can talk about it afterwards.
En dan 10 gigabit. Hij zei hoeveel bandbreedte. En dan zit hij dan 900 megabytes.
I have a question about the watch.
Sorry? It's a NAS, it's a NetApp.
No, actually.
Dat zijn de totale IOPS die gesloopt.
Yeah, well, it's the NetApp Fast. So the Fast 6280 is something. Yeah. Horrible. Any other questions or anything? Or?
And the database size?
Goes from anywhere from like a 200-300 gig up to like 4 or 5 terabytes or more. And actually we have a data warehouse environment that's like
Way too big.
yeah, in the tens of terabytes. Yes, sadly. Yeah, we have very big databases that are, because this is also my point, we have so much running on our traditional storage that is Oracle, that, you know, also with our plans to use something else, it's like, okay, so we'll use Ceph for this, and all of this is something else. Just because we need to have paid for support for this, because if we pay for the Oracle licenses, we need to run it on a supported platform. Yeah, our hands are tied. We just can't do anything else. We would like to do more and use more open source things for this, but it's reality. It's okay. If there are no more, we should go to the next one.
One question.
Here. It also exists.
Okay, one question.
Oh,
Final. Yes, you say the time is 600 seconds.
yep.
So, and you have 130,000 IOPS.
Yep.
So, on average, that's 220 IOPS only for 4K bytes.
Oh yeah, I think it's 4K. I'm not too sure. This is the Rados bench, because it's also writing what? It totally wrote 4 terabytes. If I read that right. So the write size was 41941.
That can't be 4K.
Can't be
Yeah, but
4K.
with 4K
It has
would
to be more.
quite low.
Yeah, it has to be more. Hang on. Let me just do the quick calculation.
Say 16K. That would be
600. That's going to be like 6. No, it could be 6 megabytes. It's writing 600. No, don't do it that way. 4,
Man has done a lot of benchmarks. After some time you get confused with all the data. I know it for myself.
yeah.
Yeah, I mean,
32K.
32K.
Yeah. 32K blocks.
I have a question.
My excuses. 32K blocks.
You were very concerned about the recovery and in particular the speed. It
Correct.
went too fast.
Yes.
Was it all coming from the cache tier, the recovery, or because I'm a bit surprised that you say it was too fast, it was killing your performance? Because there are options for this. For example, if you use the CFQ scheduler, you can give the client ops higher priority over the recovery ops.
Okay.
And there are lots of settings there, so I'm surprised you're saying like, I'm
Well-
stuck, you know, the way it came over.
Well, then it's basically just my ignorance.
Okay.
I admit that. So, okay, so again, I was looking more from the perspective of Ceph rather than looking at the point of view of the client. So I guess I was looking for the details from Ceph itself rather than tuning the host. So I guess that's my fault. I just looked more at Ceph.
I mean, there are Ceph settings, in particular the I/O priorities, and those are the ones that I remember the most, and the others I'm not so sure about anymore.
Okay. Well, can you give me some details, please let me know.